Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 11 of the November Daily LeetCode Challenge, and after a very long time, I think after 4 or 5 days, we are now having a question which is not related to bit manipulation. Okay, so finally the bit manipulation series has ended. So we saw XOR, OR, and operations in that bitwise. All of them are bitwise, by the way. And finally, we are having a question today which is very different from the bitwise operations. Okay, so today's question is 2601 prime subtraction operation. Okay, this question is very interesting. Okay, and I'm sure that if you are, so this is not related to programming, by the way. This is more of a mathematics related type, and here we are going to apply mathematics concept to get the answer. Okay, I will not be using any, very big kind of or very, different kind of algorithm to get the answer. I will be using the same thing to get the approach, but yeah, some mathematical concept that we are going to use. I will let you know that. Okay, so quickly starting this video without wasting any of your time. So it is 2601 prime subtraction operation. Okay, so basically you are given a nums array, if you can see here, and finally you have to return the answer in a boolean, true or false. Okay, so what do you have to do? You are given a zero index array, nums of length n. You can perform the following operation as many times as you want. Okay, what we have to do? Pick an index I that you haven't picked before. Okay, and pick a prime p strictly less than nums I. Okay, you have to pick a prime number which is strictly less than the current number that you are picking. Okay, then you have to subtract p from the nums I. See, the idea here is after the subtraction, the result should not be zero. Okay, that is why they are trying to say p should be strictly less than nums of I. That is what they're trying to say. Okay, then p, then subtract p from the nums of I. Okay, I will show you this with example if you're not able to understand this with the theory of this question. Okay, so let us move further for now. Return true if you can make nums a strictly increasing array using the above operation, and false otherwise. Okay, so if see, for example, if here, see, this 4 I can subtract with, let us say, the prime number which is smaller than 4 is 3. Okay, remember the prime number has to be smaller than the current element, so I will subtract it with 3. Okay, I'm getting 1. Okay, now this position is 1. Okay, this particular position is going to be 1 now. Next I have to subtract some number here from 9 also, such that the number counts which should be greater than the previous element. Okay, that is what I have to do, and ultimately I have to return true or false. So whether I will be able to make this array after that operation, see, that operation I can apply to any element for any number of times. Okay, so that's what they're trying to say. Pick an index I and that you haven't picked before, and pick a number p strictly less than nums of I, and subtract it from nums of I. Okay, you either can apply this operation or you need not apply this operation. Okay, there is no compulsion here. They are just either, this is optional kind of thing. Okay, if you want to apply, you can apply. If this is not possible, for example, see, let us say here the number is 2. Okay, so you cannot subtract 2 with the prime because the smallest prime number itself is 2, and the condition that they've given is p should be strictly less than nums of I. Okay, so if nums of, that is, if nums of I is going to be 2, then you cannot subtract anything from here. Okay, that means this thing you cannot do, so this is going to be optional. Okay, the only thing that you have to consider that is return true if you can make nums, okay, a strictly increasing array using the above operation, and false otherwise. Okay, a strictly increasing array is an array whose each element is strictly greater than its preceding element. So we'll try to understand this with examples. So coming to this particular example. Okay, so what they're trying to say, okay, you can go through the examples. I will quickly show you what I'm doing. Okay, but one important thing here is that you can get hold of. See here, the nums of I is going to be up to 100. Okay, up to 100. So this 100 is not a big number, by the way. So yeah, you can think about using brute force approach also. Okay, and even the length of the array is not big, but yeah, that is fine. This is going to be most important. Okay, how big the single element is going to be, because accordingly you have to choose a prime number. Okay, so that is what we're going to see. Okay, before that I will show you a quick try run of the first example. Okay, so okay, let me zoom in and let us begin this question solving. Okay, yeah, so this is going to be my first example, right? So what I'm going to do for the first time, see, I will choose a number which is smallest. Okay, I will choose a number. Okay, I have to choose. See, I will consider every prime number which is less than 4, but among them I have to choose the maximum. Okay, so all the prime numbers which is less than 4 I have to take, but among them whichever is the maximum, that is the biggest one, I have to take that. Okay, in this case, what is the prime number going to be? So okay, before that, let me show you some of the prime numbers so that you are able to see. These are going to be some of the prime numbers, in some, not everything. Okay, I've just written this for your convenience. Okay, still 29 I have written this, but yeah, the number is going to be till 1 to 100. Okay, prime numbers are going to be, see, up to 100, up to 1000 we need the prime numbers. Okay, this is just a, small set here. Okay, as simple as that. Just for your understanding, I've, written it. Okay, and see, in your code, what happens is, if you light some of these numbers, and let us say, the for example, these small cases, even this could be used as it is. Okay, you don't have to calculate them again. That is the basic idea. So if the numbers are smaller in your input, you need not calculate it, you can use this itself. Okay, so that is also another idea, right? So let us see the thing now. It is true 5. Okay, 2 3 5 7 11 13 17 19. Okay, so I'm just showing this to you so that if you're not aware of what the prime numbers are, you can quickly, recall and start using them. So the prime number, okay, among all the prime numbers which is less than 4, the biggest one is going to be 3. Okay, if I subtract 3 from 4, I'm going to get 1 here. Okay, 1 is remaining, right? Now, 9. What should I subtract from 9? So, see, the idea here is whatever I'm going to subtract from 9, the result should be greater than 1. Okay, that is what is strictly increasing array, right? The result that is going to come here should be greater than its preceding element. Okay, so what are the options for me left? Okay, the options for me is, say, I can do 9 minus 1, which is equal to 8. Okay, so the idea here is if I am going to subtract a number which is less than 8, then definitely I will have something which is greater than 1 here. Okay, do you agree with me? See, 9 minus 1 is equal to 8. What it means? What is 1? 1 is the preceding element. What is 9? 9 is the current element. Okay, so before choosing the prime number, what I'm going to see, I'm going to do 9 minus 1 is equal to 8. Okay, that is, I'm going to choose a number, a prime number which is less than 8. Okay, so that will ensure that after subtraction, the answer that I'm going to get will be strictly greater than 1. Okay, that is the idea. Okay, so I'm going to get 8 here. I need a number, prime number, which is less than 8. Okay, so which is the maximum prime number, that is the biggest prime number less than 8, it is going to be 7. Okay, I will subtract 7 from 9. Okay, so what I'm going to get, I'm going to get 2 here. Okay, I will add 2 here. Fine. Next, now this is 2. Okay, and now this is 6. Okay, so what is the element preceding to 6? It is 2 here. Remember, the array that I'm going to form this below is going to be the answer. The array that you're seeing here is the input. Remember that. Okay, so here it is 6 and here it is 2. Okay, so what is 6 minus 2, by the way? 6 minus 2 is going to be 4, right? So so that means I'm going to choose a prime number which is the biggest prime number less than 4. Okay, so what is it is going to be? It is going to be 3. So I'm going to subtract 3 from 6. Okay, 6 minus 3 is going to be 3 again. So I will add 3 here, right? Next, so what is the current element? 10. What is the preceding element? 3. Okay, what numbers to subtract? Let us get that that also done. Okay, 10 minus 3, which is equal to 7. That means I need to subtract a prime number less than 7. Remember that, less than 7. You should not subtract 7 from 10. 7 is also prime number, but you cannot subtract 7 from 10. Why? If you subtract 7 from 10, you are going to get 3. 3 is already there, right? You cannot get a strictly increasing array because of that, right? So always the element that you are going to, that prime number that you're going to select should be less than this. Okay, so the prime number less than 7 is going to be 5. Okay, so if you subtract 5 from 10, what we're going to get 5. So I can see that everywhere I am able to get a answer here. Okay, so this I can return as true. Okay, it is going to be strictly increasing. Remember that you could have chosen other numbers also. Okay, here they might have given something else also. Okay, see, 1 to 6, 10, they have given this, so this is also fine. Okay, they, what they did is they did for the first two, after that they stopped doing. Okay, because 6 and 10 are anyway, in a strictly increasing order only, so they stopped. So that is quickly, like, perfectly fine. You can do that also. What I wanted to show you my approach, right? I am doing till the last. Okay, to ensure that. And remember one more thing. So you may ask why I am subtracting the biggest prime number less than this particular element, or less than this difference. Why? See, the idea here is, for example, see, if I don't subtract the biggest number to the first element, see, if you subtract the biggest prime number from the first element, you're going to get the least possible first, okay, first integer in the array, right? This will ensure that this will give you some space more. Okay, that is, it will ensure that you can have multiple options here. Okay, in the else case, this will be very useful. Okay, so if you don't consider these things, there will be a case where your code will be failing, right? So to get that sorted, I am taking the most optimal thing here. Okay, so that is the reason. So I will give you this in the comment section if you want, but yeah, the idea is very simple. What I explained to you, that only I'm going to do in my question. Okay, so if you did not understand this, pause this video, go back by 5 to 7 seconds, see it again. Okay, this is the exact same thing that I'm going to do in my code. Okay, now next, coming to the part that how we are going to get the prime numbers. Okay, the part is, now see, prime numbers, some of them I've written here. Okay, for quick calculations. Okay, the idea here is I need not calculate everything from scratch every time. Okay, some of them can be stored here as it is. So what is the next thing, how I'm going to get the prime numbers? Okay, see, what is a prime number? By the way, prime number is a number whose, that is, no other number will be able to divide it other than 1 and the number itself. Okay, what is a prime number? Let us say the example of 7. Okay, you cannot divide 7 by any number less than it. Okay, that is, any number smaller than 7 will not be able to divide by 7 except 1 and the number itself. Okay, except 1 and 7, you cannot divide any other number with 7. Okay, no other number will be able to divide 7. That is the prime number, right? So how to get those prime numbers? So what you will do normally, what people will do is they will start a follow starting from 2, okay, less than 7. Okay, if you have to find the prime number, whether you have to check whether 2 is a 7 is a prime number or not, what you will do, you'll start a loop from 2 to okay, less than 7, that is 2 to 6. Then what you will do, you will divide 7 by each of these numbers, and you will see whether the remainder is 0 or not. Okay, if the remainder is 0, you will conclude that it is a not a prime number, as simple as that. Okay, but I will tell you another approach, and here the mathematics comes in. Okay, so what I am going to do, See, what I'm going to do is, okay, just a second. Yeah. So to check if it's a prime number, I'm talking about n equal to 100. Okay, just as an example, what I will do, start from 2. Okay, 2 is the smallest prime number, so you have to start from 2. That is fine. But I will go till square root of 100. Okay, that is square root of the number itself. Okay, if you have to check a number is prime or not, you have to go from 2 to the square root of n. Okay, why like that? That is, in this case, it's 2 to 100, 2 to 10 for the number 100. Why? So here is the explanation. See, these are some of the factors. Okay, here are some of the factors, that is 2, 5, 10, 20, 50. Okay, these are going to some of the factors of 100 which can divide 100. Okay, so why, so you will tell me like here 50 is present, so why you want to restrict till 2 to 10 only? So I will tell you that. See, 2 I am getting here, 5 I am getting here, and 10 I am getting here. Okay, now if you see here 50 is coming, but you could have got 50 by 2 itself. Let's see, remember, when you try to divide 2 with 100, you are going to get 50. Okay, so 50 is coming because 2 is there, right? 2 into 50 is going to be 100. So if the idea here is within these, okay, if you try to divide 100 within these numbers, okay, if a number divides, that means above with that also there will be numbers which will divide. Okay, that is the basic idea. Okay, so if you see here, out of all these three, if you see, everywhere there will be one number between 2 to 10. Okay, that is the basic idea. That is, within this, if you are getting a number which is able to divide the 100, that means it is not a prime number. You can conclude that. Okay, so this is one of the mathematics thing that I'm using here in this solution. Okay, you can check this out, the actual reason of why it works, but I've given you an example here. Okay, so always check from 2 to the square root of 100. Okay, for example, here 10 is coming, let us say it is coming something like 9. For example, if you take square root of 7, it will come 2 point something. Okay, in that case, take the ceiling of that. Okay, so just take the ceiling of that. For example, 2.73 came, just take it 3. Okay, then 2 to 3 you will have to check that. Okay, that means if a number between these two divides, then it is not going to be a prime number, as simple as that. So that is about how to find the prime number. Now let us start the solution. Okay, so what I'm going to do, first of all, if you see here, the maximum number that I'm going to get is going to be 1000. Okay, fine. What I will do here, see, I'm first of all calculating the max of the current nums array. Okay, why I'm calculating that? Remember that whatever is the maximum n is going to be, that is the maximum element in this particular array. I need to find prime numbers only till that. Okay, remember, let us say in this the number is 10. That means I need prime numbers only up to 10. Okay, whatever are prime numbers up to 10 only, because that is going to the max that I will be using to subtract. Okay, so for that reason I'm calculating the max here. Though I have calculated till 30 already, but still, just to ensure that we are not exceeding that, that is, let us say here 999 came, so I have to find some more, right? For that reason I'm doing that. Okay, so I'm calculating n, which is the nums. Okay, I'm calculating the maximum in the given array. What I'm doing next, I'm starting from 30. Why? Because see, till 20 I've already calculated. Okay, so I'm starting from 30, I'm going till max. Okay, as simple as that. Remember, when I write this in Python, that means I will be going till max minus 1. Remember that always. Okay, because remember, the prime number that you're going to choose should be strictly less than the number I. Okay, the prime number should be strictly less than. So through this I'm ensuring that. Okay, if you write max, that means you will be starting from 30 till max minus 1 only. Okay, that is the first thing. Next, what I'm going to do, I will see, this is for going to be for the prime number. Okay, this first two is going to calculate the prime number. Okay, next for loop will be calculating whether this I is going to be is divisible by any of its number less than that or not. Okay, so for that, what I'm going to do, I will start from 2 and I will go till square root of I. Okay, square root of I, and I'm doing a plus 1 also. For example, let us say 49. So what is square root of 49? It is going to be 7. So 7 is going to divide that, right? So that's why I will go till 8. Okay, so starting from 2, you have to write 8, 2 comma 8. Okay, basically 2 comma 8. Why I'm writing 8? Because I need 7 also to be participated in the division process. Okay, so if I write 8, then 7 will be able to participate. Remember, whatever number you write in this particular place, one less than that will be used. Okay, is one less than that will be the final number to which this for loop will go. Okay, so that's why I'm doing a plus 1 here. Okay, and in Python, this star refers to the power of. Okay, here I'm doing I raised to the power 0.5, that is square root of 5. Okay, that's what I'm doing here, and I'm also taking a ceiling of that. So for example, 2.73 came, I'm going to take 3 here. Okay, so that is what the ceil operator means. Okay, then what I'm going to check, I'm going to check whether j is able to divide I or not. Okay, if j is able to divide I, that means it is not, definitely not a prime number. You can break out of the loop. Okay, you can go to the next I, just like that. Okay, if this whole for loop completes without breaking, only then the else condition will be executed. Remember, you can also write else condition for after a for loop. Remember, there's no if condition here. This is another Python concept. Okay, after the for loop you can write a else condition. What that means, if this for loop completed successfully, only then the else condition will be executed. If this for loop got broken in between, that is, this break statement got executed, then this else condition will not be executed. Remember that. This is a Python concept. This is not something new that I'm teaching you, right? Fine. So that means if the whole for loop completed without a break, that means I is going to be a prime number. So I'm going to add I in my prime list. Okay, what is the prime? Basically, prime is going to be a set of the prime numbers. Okay, as simple as that. Fine. Next is a function. Okay, what is this function going to do? I'm going to pass a number n here, num. Okay, what it will do? It will find the among all the prime numbers, which is the maximum biggest prime number less than num. Okay, it will find the biggest prime number less than num. Okay, and it will return that. Okay, first what it will check whether the num is less than equal to 2 or not. Remember, 2 is going to the smallest prime number. Okay, if the num itself is 2, that means I cannot provide a prime number which is less than 2, right? The biggest prime number less than 2 is not possible here because the smallest prime number itself is 2. So that is why if the number is less than equal to 2, I'm returning -1. As simple as that. What I will do next? Next, I'm going to start a loop. Okay, this loop will run from n minus 1 to 2 in a reverse order. Okay, it will start from num minus 1, it will go till 2. Okay, what it will do? See, it will start on num minus 1 and it will go till 2. Okay, you will ask me why I'm writing 1 here. See, in Python always this place whatever you write, okay, 1 less than that or 1 more than that will be taken. Okay, here it's a reverse because I'm going in a reverse direction, right? So I want this loop to go till 2. So I'm writing 1 here. Okay, as simple as that, right? It will go from num minus 1 to 2, right? It will check whether the I is in prime or not. Okay, prime set or not. If it is in prime set, that means I found a number I, okay, which is less than num, but it's the biggest prime number. Okay, so the prime number, the biggest prime number less than num is going to be returned by this particular function. Okay, I'm going to return I here. Let us say I did not return anything after this within this for loop. I have to return -1 then. Okay, as simple as that. Okay, so what this function will do? It will return the biggest prime number less than num. Okay, as simple as that. Fine. Now let us start the first thing. Okay, I will process the 0th element separately, and for the first element I will start a for loop to process that. Okay, so let us see what I'm doing. First of all, I'm declaring a variable called largest edgeable prime. Okay, what I'm doing here, I am calling this particular function that I declared previously. Okay, this function will give me the biggest prime number less than the parameter pass. Okay, less than num. Okay, so what I'm passing, I am passing nums of 0 first. Okay, the 0th element. Okay, this will return me the biggest prime number less than the first element of the array, that is the 0th element of the array. Okay, so that number will be given to me. I will check whether that number is not equal to -1. Okay, if it is not equal to -1, what I will do, I will subtract nums from this particular number. Okay, nums of 0 is equal to nums of 0 minus that particular number. Okay, I will be also doing this print just for you to understand it easily. Okay, fine. Then I'm printing the array with a 0. What is 0 means? 0 basically means that the index for which the replace happened. Okay, this is just for your purpose. This is nothing to do with the code. Okay, next I'm starting a for loop to do the same operation for the other element, that is starting from 1 to n minus 1. Okay, what I'm doing, if nums of I is, that is C, for the first element there's no previous element, right? That is why I've done it separately. But for every other element there will be element which is previous to that. Okay, that is one element prior to that. Okay, so what I'm going to check first of all, whether the ith element is less than or equal to this previous element. Okay, if the ith element is less than the previous element, then we cannot do anything. You have to return false. So what that means, see here, let us see this. Okay, okay, let me show you from the example. Fine. So this 4, okay, this is the 4 after the, let me zoom in, this is a 4, right? After subtracting from the biggest prime number, it became 1. Okay, fine. But let us say this element is 0, okay, or this element is 1. So I have 1 here, I again have 1 here. Okay, that is, it cannot be a strictly that is strictly increasing array, right? So it is not possible to find a strictly increasing array in that case. Okay, so for that reason, what I'm doing, if, yeah, if nums of I is less than equal to its previous element, remember even equal to is there. Okay, less than or equal to its previous element, return false. Otherwise, what I have to do, I will calculate the difference between the nums of I and nums of I minus 1. That is the current element and the previous element. Like the way I did here, okay? Like this I did, no? 9 minus 1 I did here. See, 9 is the element here, okay? 9 is the element here, 1 is the new element here, okay? So I did 9 minus 1, which is 8. I need to find a prime number which is less than 8, okay? The biggest prime number less than 8. That's what I'm going to do here, okay? I'm calculating the diff, subtracting the current element, that is subtracting the previous element from the current element. Okay, I'm finding that. Next, I'm going to pass this diff to this particular function, find biggest prime number less than num. I'm going to pass the diff in that. Okay, this will return me the biggest prime number less than diff. Okay, this is going to be that. If it is not -1, what I'm going to do, I'm going to do the subtraction. Nums of I is equal to nums of I minus this particular number, as simple as that. Okay, this loop will continue till the last. If till then nothing happened, I will return true. Okay, otherwise there will be a case where I have to return false here. This is the only kind where the only place where I'm returning false. Otherwise, I'm not returning false. Okay, let me quickly run this and show you how it works. I will again trace the first example with this, and yeah. So yeah, let me increase this and reduce the zoom. Yeah, so let us start now. See, here 4 is there, right? So what I'm going to do, I'm going to subtract 3 from 4. So what I'm going to get, I'm going to get 1 here, okay? And rest of the elements, okay, remains the same, okay, after the first thing, okay? Next, what I'm going to do, next element is going to be 9, right? Next element is 9. So what I have to do, see, subtract 1 from 9. What you're going to get, you are going to get 8. That means you need to find the biggest prime number less than 8. What it is going to be, it is going to be 7. So I will be subtracting 7 from 9 now. What I'm going to get, I'm going to get 2 now, okay? So these two are done, okay? These two are done. Till then it is fine. Next is 6. So what I will do, I will subtract 2 from 6. I'm going to get 4. So I need to find the biggest prime number less than 4. What is that? It is going to be 3. So I will subtract 3 from 6 now. So what I'm going to get, I'm going to get 3. So I will add 1, 2, 3 here. As simple as that, okay? Next 10 is there, okay? So I will subtract 10 from its previous element. That is, I will subtract this element. That is, I will subtract previous element from 10, okay? 10 minus 3, it is 7. So what is the biggest prime number less than 7? Remember, 7 is also prime, but I want a prime number less than 7. Biggest prime number less than 7, it is going to be 5. So I will subtract 5 from 10, okay? What I'm going to get, I'm going to get 5 again. So till then it worked, okay? Everywhere it worked. That is, every element is greater than its previous element, even after subtraction, even before subtraction. So finally we have array, okay, which is strictly increasing, so we can return true. Okay, I return true here. If you see, that is going to be the output. Okay, fine. Let us see one case now where the output is false. Okay, yeah, here the output is false. Let us see that. Okay, what I did first number is 5. Okay, so what is the biggest prime number less than 5? Okay, it is going to be 3. So what I did, I subtracted 3 from 5. So what I got 2 here. Okay, fine. Next is 8 is there. So what I will do, I will subtract 2 from 8. I am going to get 6. Okay, what is the smallest prime number? Which there is the biggest prime number less than 6, it is going to be 5. So I'm subtracting 5 from 8. Okay, I'm going to get 3 here. Fine. But now next element is 3. Whether 3, that is this element, is greater than its previous element? No, it is not greater than its previous element. So there is no way I can make this as a strictly increasing array. We cannot do that. So where it will fail, this will fail in this condition. Okay, this condition it will fail if nums of I is less than equal to its previous element. Okay, that is the current element is less than or equal to its current element. I cannot do anything here. So I did everything optimally. Okay, I subtracted from the biggest prime number its previous elements. Still I am getting 3 only. I cannot take this below 3. Okay, so I cannot do much anything. Okay, I cannot do here much. So I have written false here. So this is going to the case where I'm going to written false. Fine. So yeah, this is also true. And the fifth case, yeah, this is also going to be true. Then if this is a similar case, okay, if you want, I can trace this also. But yeah, this is just going to be same as the previous example. So this is how it works. Okay, this is the solution. So here, what we did optimally is a one optimal thing that we did is we are going from 2 till the square root of the number. Okay, this ensures that we are calculating the prime numbers with a minimal you know t- computing power. Okay, that is the first thing. Okay, this ensure that, and one more thing is we cached some of the prime numbers. Okay, so that if we are going to get an input which is having smaller numbers, we don't have to calculate the prime numbers again. That is the first thing. Okay, other than that, even if a big number comes, we are using optimal approach to get the prime numbers till then. Okay, next thing is we utilize this fact also. Okay, it is going to be till 100. That's why brute force approach is possible, that we did. Okay, then I'm going to have a function here which is giving me the largest prime number less than current num. Okay, this I used and I did the rest of the calculations here. Okay, so this was one of the questions that we had. Okay, I felt there is a lot to learn here. Okay, this is more on the math side. I agree, but yeah, there is definitely a part to learn here because it's also on the arrays. Okay, so this can be solved using multiple approaches, but yeah, the approach will depend on how you are finding the prime number. Whether, see, you could have used some sophisticated algorithms. Okay, there are some algorithms also to find the prime numbers. Okay, which are using some sophisticated graphs and doing that. Okay, you can do that also. It will increase the space complexity, but yeah, the compute time, that is the runtime, will be reduced. That is true. I agree with that, but yeah, before that also you can get this kind of solution done. Okay, and here also I'm using optimal approach only. Okay, this is going to be the most optimal approach. Okay, you can do. Okay, you can search about it in the internet, you will get this approach. Okay, here we are going from 2 till the square root of that number to check whether the number is prime or not. Okay, so to find its factors. So yeah, friend, that was all for today. This was really a good question for me to this will really test your knowledge in math, that is true, but yeah, other than that also it will test how you're able to process the things. Okay, subtracting a number and then checking whether it's less than that number or not, these things you will get to know only if you take a pen and paper and start tracing how I'm going to get the answers. Okay, that is where that's why this kind of questions are very important in the real face-to-face interview. Okay, they will test whether you are able to analyze the facts properly or not. See, always observation comes first. Okay, then develop brute force solution and then try to optimize it. Okay, that is what they are really expecting you to see. They are just trying to see whether you are able to solve problems or not. Okay, that is also important. You can expect this kind of question in the real interview, because if you're an engineering student, then definitely you should be good in the math side also. You cannot say that it's a maths question, that's why I'm not good in that. Okay, that is not acceptable solution. Okay. So yeah, friend, that was all for today. If you like my efforts, please do subscribe to my channel. It takes a lot of efforts to make this video daily for you. Okay, remember, videos, I'm not saying efforts are needed, I'm saying to continue daily efforts are needed, right? If you subscribe, this really gives a lot of motivation to continue further. Okay, this will help you also in a long run. At the same time, this will give me a motivation to do this, to continue this. So yeah, friend, that was all for today. If this video adds even a single, it's something more to your brain and something more to your career, please do subscribe to this channel. This really gives a lot of motivation to continue further. See you tomorrow. Thanks a lot.